In this video, I'm going to talk about different forms of linear equations. The three main forms of linear equations are the slope-intercept form, point-slope form, and standard form. Please pause the video and study each of these for a moment. Now let's graph this equation. This equation is written in point-slope form, and you should be able to see that the 2 took the place of the m. You should also notice that the 1 took the place of the y1. To see why I say that positive 1 and not negative 1 took the place of the y1, notice that the point-slope formula talks about y subtract y1. Also notice that the x1 is a negative 3. This tells me that my line passes through the point negative 3, 1, and so I will plot that point on my graph. Next, let's talk about the slope. The slope, as I said earlier, is equal to 2. And since slope is equal to rise over run, I can start at the point I just plotted and rise 2 and run 1, and then rise 2 and run 1 again. Since negative 2 divided by negative 1 is also equal to 2, I can go back to my original point and rise negative 2 and run negative 1. And now I can draw a straight line through my points and put arrows on the ends because it does not stop in either direction. Now let's work another similar example. You should be able to see that the slope of this line is negative 3 halves. You should also realize that my y1 for this problem is 0 because y minus 0 is equal to y. Also notice that my x1 is negative 4. This means that the line passes through the point negative 4, 0, and so I will start by plotting that point on my graph. Next, since my slope is equal to negative 3 over 2, I can rise negative 3 and run positive 2 from this point, and then rise negative 3 and run positive 2 again. Since positive 3 divided by negative 2 is also equal to negative 3 halves, I can go back to my original point and rise 3 and run negative 2. And now I can draw a straight line between these points and put arrows on the ends. For the remainder of this video, I will talk about how you can take some information that is given to you about a line and write an equation of the line. For this example, you need to start by finding the slope. You can use the formula y2 minus y1 divided by x2 minus x1 if you want to, but when you have a graph drawn for you, I think it's easier to use the formula slope equals rise over run. Note that if you pick 2 points and use this formula, you should get a fraction that reduces to 2/3. Next, I will note that this line passes through the point negative 3, negative 4. That means I can substitute the numbers into the point-slope formula as you see here. For my last step for this part, I will note that y minus negative 4 is equal to y plus 4, and that x minus negative 3 is equal to x plus 3. It is important to realize that I could have picked any of the other points on the line and substituted the corresponding values for x1 and y1 as you see here. All of these answers are equivalent and equally correct. To write the equation in slope-intercept form, I will take the answer I got from the last step and rearrange it so that it has the form y equals mx plus b. I will start by using the distributive property to get rid of the parentheses. Note that 2/3 times x is equal to 2/3 x, and that 2/3 times 3 is equal to 2. To finish putting this in slope-intercept form, I will subtract 4 from both sides of the equation. To put this equation in standard form, I will rearrange the equation from the last step. Note that the formula at the top of the page says that the x and the y must be on the same side of the equal sign, and so I will start by subtracting 2/3 x from both sides of the equation. Next, because the numbers cannot be fractions, I will multiply each term by the least common denominator. Note that negative 2/3 times 3 is equal to negative 2, that y times 3 is equal to 3y, and that negative 2 times 3 is equal to negative 6. And finally, because the number in front of the x cannot be negative, I will multiply each term by negative 1. This question is a little different from the last one. Because the slope of a vertical line is undefined, we cannot substitute a number for m into the point-slope formula. However, this question is actually very easy. Pause the video while you pick some points on the line and find the x and y coordinates of these points. You should be able to see that the x-coordinate for every point on this line is -5. And so I can say that the equation x equals -5 describes this line. To work this problem, you can note that the slope is 0 and then use the point-slope formula. However, the easier way to work it is to note that the y-coordinate at every point on this line is 6. Therefore, I can say that the equation y equals 6 describes this line. Now let's talk about parallel lines. I'm hoping that you already know that two lines in a plane are parallel if and only if they never intersect each other. And if you think about how the slope of a line talks about its steepness, you should realize that it makes sense to say that two lines in a plane are parallel if and only if they have the same slope. That means that, in order to work this problem, I have to start by finding the slope of x minus 5y equals 15. And, in order to do that, I have to rearrange it into the form y equals mx plus b. So now I can say that the slope of my old line is 1/5, and since I want my new line to be parallel to this one, and since parallel lines have equal slopes, this means that my new line must also have a slope of 1/5. Now I can substitute numbers into the point-slope formula. Note that the question says that the new line is supposed to pass through the point 4, -1. To check this answer, I can graph both lines. The red line here is the graph of the line x minus 5y equals 15, and the purple line is the graph of the equation that I just found. Note that these lines do appear to be parallel, and that the new line does pass through the point 4, -1. To write the equation of this line in slope-intercept form, I will take the answer I got in part A and rearrange it so that it has the form y equals mx plus b. I will start by using the distributive property. If you don't know how to multiply the fractions, you can use your calculator to do it for you, or you can go watch my video on fractions. Next, subtract 1 from both sides of the equation. Again, you can use your calculator to do this for you if you want to. To check this answer, you can graph both equations. Again, note that these lines do appear to be parallel, and that the new line does pass through the point 4, -1. To write the equation in standard form, I will rearrange the equation from part B. I will start by subtracting 1/5 x from both sides of the equation so that I have the x and the y on the same side of the equation. Next, because I cannot have fractions or decimals in my answer, I will multiply both sides by the least common denominator, which, in this case, is 5. Finally, because the number in front of the x cannot be negative, I will multiply each term by -1. And, of course, we can check our answer by graphing both equations again. Next, let's talk about perpendicular lines. I'm hoping that you already know that two lines are called perpendicular if and only if they intersect to form 90-degree angles. What you may not know is that this means that their slopes must be opposite reciprocals. This means that, in order to find the slope of a line that is perpendicular to another line, you must take the reciprocal of the old slope, or, in other words, flip it upside down and change the sign. To answer this question, the first thing I need to do is find the slope of the new line. The slope of the line y equals -3/5 x plus 1 is -3/5. Since perpendicular lines have slopes that are opposite reciprocals, I can say that the slope of the new line will be +5/3. And now I can substitute numbers into the point-slope formula. Note that this question said that my new line should pass through the point 0, -2. Now I can simplify the equation slightly by noting that y minus -2 is equal to y plus 2, and that x minus 0 is equal to x. Since the question did not specify a form that I should leave my answer in, I can leave it like this. And finally, I can check my answer by graphing both lines. The original line is the line in red here, and the new line is the purple line. Note that they do appear to intersect to form 90-degree angles, and that the new line does pass through the point 0, -2.